Today we're going to start chapter 17 and 18, so reflection and refraction. So the first section or the first chapter is chapter 17. It's all about reflection specifically. So the first thing you need to know is what the law of reflection is. The law of reflection states that the angle that a reflected ray makes, as measured from the normal, is equal to the angle that the incident ray makes, as measured from the same normal. Okay? So basically, theta r, your reflected angle, is equal to theta I, your incident angle. Okay? So let's take a look at what that's supposed to look like. So here we have your incident ray coming in. You have your theta I with the normal. Now, normal, remember, is a perpendicular to your surface. Okay? So when that incident ray comes in, it's going to hit your surface. Because it's reflected, it's going to bounce off at the exact same angle to give you your reflected ray. So theta r and theta I are equal. So here's an example. A light ray strikes a mirror at an angle of 52 degrees to the normal. I want to know what's the angle of the reflected ray. Well, obviously 52 should equal 52. Now, I might also ask you what is the angle between the two rays. So you would do 52 plus 52, and you would get 104 degrees. Okay. Make sure you read where your angle is. If it says that your angle is to the normal, that is your theta r or theta I. If it says that your angle is to the mirror or to the surface, then you need to calculate to see what your theta r or theta I is. If you'll draw pictures, it will help you with these. So moving on, chapter 18, refraction. What is refraction? It's the bending of light as it moves from one medium into another. So from one type of material into another. So from air into water, from air to glass, that sort of thing. We have what's called the index of refraction. That's something that you need in order to determine your angles in this case. So it determines how things are refracted. So index of refraction, that goes along with your mediums. And we're going to be using Snell's law for this one. So N1 sine theta 1 equals N2 multiplied by the sine of theta 2. Okay, so N1, that's your index of refraction for medium 1, whatever it is, so where you're starting. Theta 1, angle of incidence. N2, index of refraction for medium 2, so what you're going into. And then theta 2, the angle of refraction. So when we talk about index of refraction, we have some numbers here. You also have a chart on the very front page of your reference packet that has some numbers that are similar to this. So if you look at this, we have the vacuum, which is 1.00. In your chart on your reference packet, it actually says that air is 1.00. Well, air is really close to 1.00. You can use 1.00 or 1.003. Okay, this number will get you just about as close as 1.00. Okay, water is 1.33. Ethanol, that's like alcohol, 1.36. Soda lime glass. There are some other types of glass as well, but soda lime glass, that's one of the ones from your examples, 1.52. Quartz, 1.54. Flint glass, 1.62. And diamond, 2.42. Okay, you will need this chart later. This is in your iBook for physics, or like I said, you do have a similar chart on the front of your reference packet. So let's go ahead and look at an example. A beam of light in air hits a sheet of soda lime glass at an angle of 30 degrees. I want to know what is the angle of refraction of the light ray. So here's our information. We have N1 sine theta 1 equals N2 sine theta 2. So we need to go ahead and plug in our numbers. We know that N1, our first medium, is air, so we can plug in 1.00 for that. We know that sine theta 1 is coming in at an angle of 30 degrees, so that would be sine theta 1. N2, if we go back and look at the chart from the previous page, you can see that soda lime glass is 1.52, and then theta 2 is what we're looking for. So when you plug in these numbers, we have our air, we have our angle. Soda lime glass, I have 1.54 here, but that should be 1.52, and theta 2. So we want to get 1.54 away from sine theta. So we divide, puts it on this side. And you can go ahead and plug all this in. I would suggest plugging in a second set of parentheses here and here so that you do this calculation before it divides. Okay. Once you find this number, in order to get theta by itself, we need to do inverse sine. And so inverse sine of that big long number there. And your answer should be, and you should get 19.26 or thereabouts for your theta. Okay. So there are some practice problems in your iBook on page 1156, number 1 through 5. So if you can either stop the video now and go do those, or you can leave space and then come back to those at the end. But there are some other things that you need to know as well. There is a way that you can find the index of refraction, and it's by this formula. N is equal to C over V. That should be a V, not a Y. So N is the index of refraction. C is the speed of light in a vacuum. That's a constant number. It is on your reference packet. And then V should be the speed of light in the medium. Okay. So we'll look at an example for this in a minute. Total internal reflection. So this is when an object comes into, or when you have a light ray that comes into a medium and it stays in the medium. It does not escape. And I'll show you an example of this in class today. So this is what we have. We call this a critical angle. So that means when it hits it, it's not going to reflect. It's not going to refract. It's going to stay within that area. So N2 divided by N1. And that is a little deceiving. So theta C, that's your critical angle. That's the angle that causes this total internal reflection. N2 is the index of refraction for medium 2. N1 is the index of refraction for medium 1. Now, however, if you go to plug this in and your N2 is larger than N1, you will not get a calculation. So whichever medium has the smaller index of refraction, that's the one that goes on top. So for example, if you have air and water, air is the number that goes on top, water is the number that goes in the bottom, because 1.00 is smaller than 1.33. Okay. We also have mirages in refraction. And the way you get a mirage is you have different atmospheric densities. And as a light ray passes through those different densities, it causes refraction. Okay. So think about if you stick a straw into a glass of water. It looks like that straw is bent or broken. And that's what the light is doing when it's moving through different atmospheric densities. It's breaking that light ray and causing this distorted, almost like an image to appear. And that's it. So we'll do some practice with internal reflection with finding index of refraction. Make sure you know those formulas. You do have an assignment for today, and it is a group assignment.